Another set of data is modeled here. Now this is data set 3 in your notes if you're in my Algebra 2 class. But we can also use this for other demonstrations. Remember, in order to use the rules with differences or ratios, I have to have a constant interval going down my axis. When I look at my x column, I can see each term is increasing by a value of 2. 1 to 3, 3 to 5, 5 to 7. So I can actually use this analysis. I want to compare the first differences to see what I get. So for example, 11 minus 3 gives me 8. 27 minus 11 is going to give me 16. 51 minus 27 is going to put me at 24. 83 minus 51 puts me at 32. And 123 minus 83 puts me at 40. Now looking down this column of first differences, I don't see I have a constant value. That means that this data is not linear. A linear line, a graph, a line, will not fit this data very well. I could force one in there. When you do more stats, you'll find out how that works. But it looks like based on the fact that these differences are not the same, that's not a very good fit. So my next thought might be to look at the second difference. I'm going to do this by comparing the differences of the differences. So for example, I'll take 16 minus 8 and see what I get. That's going to give me 8. And I'm going to repeat that process going down the line. 24 minus 16 puts me at 8 again. 32 minus 24 puts me at 8. 40 minus 32 puts me at 8. When I compare the second differences, that shows me that I have a constant value. If the second difference is constant, then I'm looking at a quadratic as my best fit. As we've learned earlier, a quadratic expression is any equation I can write that fits the form ax squared plus bx plus c. So I can use that as a tool in order to figure out what equation would best model this set of data. For now, the most important thing is that we're going to be checking the second differences. I run the first differences first, see if I get a constant value. I did not. So I'll compare my second differences. Since I did get a constant value, I would refer to this data as best fitting the quadratic model.